Okay, so we'll start, Julia, and people will come on, hopefully. So this is what happens. Don't stop now because the home stretch is where everybody wants to quit in the race, but you got to put on the steam, right? Okay, so we're going to start with these topics. And on the first page, a function represents the relationship between inputs and outputs. Unlike an equation, a function by definition has only one corresponding output for each input. So this is not a function, but this is. You've had that in school for a while. Functions weren't even on the test 10 years ago. So this is pretty easy. So if f of x equals 3x plus 5, whatever in the parentheses, that's what we put in for x. So you could just do that. That's going to be 3 times 5 is 15 plus 5 is 20. Then when we put 2 in, we're going to get 11. And so the answer will be B. And that's good, right? It's easy. Okay. So here's where they're giving us f of k. So they changed the variable, but don't let that confound you. We're trying to get k. So we know this is going to be f of k, actually. So we're going to put 5 is 2k minus 3. We add 3. 8 is 2k, so k would be 4. Good. Let's do some book problems. So the first one is page 365, number 10. There's about 8 questions on the test from this packet, so it's pretty heavy on the packet. So on 365, number 10, go ahead, give it a try and see what you get. So D320, right? That's good. Okay, let's try another one on that same test, 373, number 6. So they did change the variables again on us, but that should, so f of a is 10. Hi, Dominic. We're doing the function packet. Uh, it's this one. We're just trying some book problems. We just started. Good job. So 10 equals, there's about 8 questions from the test on this. So we know that's a 5, sorry. I'm on 373, trying number 6.
That's x plus 15 over 5.
Oh, I'm sorry. Yeah. So we'll multiply both sides by 5. Subtract the 15. and x will be, let's see what I do wrong here. Oh, I'm subtracting 15. So x is 35C. Is that good? Dominic, good? Okay, let's go to another one. So we're going to go to 733, number 17. So this is a higher difficulty, but it doesn't look that hard to me. So give it a try. So we're just going to put 4 in for x. So did you get D? D is good, Dominic? That was a higher level. I don't know why, but we're high up in the module too. Okay, and we want to do just a couple more. Let's go to 835, number 21. Hmm. Oh, I did this one now.
Yeah, I think you do that one later, maybe.
Yeah, I'll do that one later. Sorry. Okay, so we won't do that one right now. So let's go back to the packet. Sorry about that. Okay, so we're back at the packet. So let's look at this one. For the function defined above, a is a constant. And so if we put in 4, we should get out of 4. So our job is to get the a. It's like a mystery. So we'll have ax squared plus 8. And and we put 4 in for x, so 4 squared is 16. That makes sense. Then I'm going to subtract the 8. So negative 4 is 16a. Divide by both sides. So a is a negative 1/4. Now I can put it back in. So I have, just going to write it up here. G of a negative 1/4 equals, I know
No,
that,
the A is negative 1/4.
I know I'm putting in -4 for the G
Oh,
function.
okay.
Okay, so this will be minus 1/4 times -4 squared plus 8. And I'll still get 1/4 of 16 is 4. But it'll be a -4 because there's a negative here. -4 plus 8, and I'll still get a -4.
You
No, I'll get 4. Sorry. Okay. So is that one good? Okay, good. Let's try this one. We want to do 2f of x. So that'll be 2 So that's just going to be 6x plus 8 plus 4, 6x plus 12. Answer choice D. Okay, so for this one, A is a negative number. Now I'm going to just pick a number. I'm just going to say A is a -2, but you can do what you will, because we will have 1/2. X would be a -2 plus a -2 in the perpendicular lines is absolute value. So this will go to 0, and 1/2 of 0 is 0. Thank you, College Board, for 10 points. Is that good, Julie? Dominic, we're good with that one? Okay. Now this is a harder page. So with this one, we sort of have to be a detective. So we have f of x equals a to the big X. So we just follow the yellow brick road. So we're going to put 0 in for x, and that'll be 4 equals a b to the 0. And so any number to the 0 power is what? It's 1, right? So this will go to 1. So we know a is 4. Now the next part of the mystery is this. We get another clue. So if we put in, we're going to get f of 1 is 8. So 8 equals 4 times b to the 1. And so the only thing b can be is 2. Now we have the equation for anything. So we can do f of 3 will be 4 times 2 to the third, which is 8, and 4 times 8 is 32. So since that was a hard one, I could do it again. Just give me a thumbs. Julie, are you good with that one? Julie, are you good? Dominic, should I do it again?
Probably at the end of it,
Okay.
near the end of the equation.
Yeah. So did you get the A was 4 part?
Yeah, yeah, a fourth, yeah. Or a
Okay.
equals 4, yeah.
Then I put in 1 for X, and I get 4 times something equals 8. So that means the B part has to be 2. So that makes sense there?
Oh, yeah, yeah, yeah.
Okay, now you had your epiphany. So you know we're just going to have 4 times 2 to the third, and that'll give us 32. That was a hard one. So if we go on to 6, let the function f be defined by f of x equals 5x minus 2c. We're trying to get c. So we'll put in 10 for x. So that'll be 5 times 10 minus 2c plus 5 times, we're putting 5 times 5 minus 2c, and that whole thing will equal 55. So that's 50 minus 2c plus 25. That's a 5. I'm sorry, this glass is hard to write on. Logan! Yay! Let me just get Logan caught up. So, Logan, we can't see your beautiful face. There you are. But we're doing functions, honey. And so you get that packet out. We'll wait for you. We just started. And there's about 8 questions from this packet on the test, so it's good that you're here. So this will be I'm on the page. We just started, so I'm on
You're on page 4.
page 4. Thank you. And so we're trying to figure out what this value of C is. So we put in, so that's going to be 50 plus 25 is 75, minus 4C is 55. So we subtract the 75, and I'll just move over here a bit. Negative 4C equals negative 20. Divide by minus 4, so C is 5. And I realize you're just jumping in, Logan, so that makes probably sense for you. So we're just starting off in functions. So number 7 says, let the function f be defined by f of x equals 3x minus 4 for all values of x. So if we put in a 4, we should get out a t. So that'll be 3 times 4 minus 4. 12 minus 4 is 8. Now we're doing f of 8. So we're going to put the 8 back in. So that'll be 3 times 8 minus 4. 24 minus 4 is 20. Thank you, College Board, for 10 points. So that's all good with everybody. Julia, thumbs up. Dominic's good. Logan, you're good too. I figured you could jump on. Okay, this one's a little trickier because we're putting x plus h in for the x squared. So this will be f of x equals x plus h times x plus h minus 2. We have to FOIL this, so that'll be x squared plus 2hx minus 2, which looks like b. So that makes sense to everybody? Thumbs up.
You lost your h squared somewhere.
Oh, sorry, yeah. I didn't put the h squared in. Thanks, Jim. Okay. Now the next one. Okay, this is a little harder because, and this would be at the end of the test. Because for what's happening here is they didn't ask for f of x. So that should trigger an alarm in your head. And this would be at the end of the test. We're wanting f of minus 3. So if f minus 2 is my negative 3, then really x is a minus 1. Actually,
They translated the function.
They translated the function 2 to the right, right? If it's negative, it goes to the right. That's the tricky part. So now we just put in f of minus 1, and we're going to get minus 2 plus 4, which is 2. Does that sort of make sense? That's harder because they're not straight away giving you f of x. Okay, so Julia's good with it. Dominic, sort of. It's hard because you're moving negative 3, 2 to the right. We're going to go over how you move the functions in a minute. So that one's pretty hard. Let's look at this one. For the function f, if we put in a 1, we get out a 3. If we put it in 2, we get out a 1, which could define the function. Well, one strategy is just to put the numbers in. So if we put in a 1 here, we don't get 3. If we put a 1 here, we get a 2, so that doesn't work. A 1 here, we do get a 3, but a 1 here, we're going to get minus 6 plus 5, which is a negative 1. So the answer for this one is going to be D. because it has to work for both functions. Does that make sense? Nodding heads. Okay, let's try a book one like this. So we're going to go to 224, number 10. Like I said, 80 points on the tester from this math pack. Okay, this isn't so bad. So try it with me. See if you can beat me to the answer. F of x is x plus 7 over 4. We want to get f of 9 minus f of 1. So you're first going to put in a 9. So try to beat me to the answer. How many got B2? Just raise your hand if you got B2 or your thumb. Thanks, Julia. We'll give them time to complete it. So you're just putting 9 in first, and then you're putting a 1 in. Oh, good. Thanks, Logan. Dominic, are you good with that one? Oh, good. Okay. So let's go back to the packet. So here, we could go in the math door, the actual math, or the strategy door. So the table above shows values of the function f for corresponding values of t. It's a line, so we know it's linear. Which of the following defines f of s? So the math door, we already know that the y-intercept is going to be -1. And if we pick 2 points, I'll just do 1, 1, and 2, 3. This is the math door. You would just do 3 minus 1, 2 minus 1, and you would get 2 over 1. So the slope is going to be m. So we know based on this, it's going to be f of t equals 2t minus 1. But what I could have done is I could have put these numbers in. But do you see how a is a trap? Because if I put 0 in for t, I do get a -1. But then if I put a 1 in, I don't get a 1. So they tried to deceive you to pick A. But if you tried all 4 numbers, D would work. So does that one make sense? And you can pick the math way or the strategy way. Any questions? We're doing great. Okay, let's go on to the next page. Wait, hold on. Okay. Here's another one sort of like this, and I wanted to do it with. So we want to get this equation, and we want to get this missing value. So one thing we could do is we could get the slope formula out, because we're going to need that for other questions. And so that's going to be y2 minus y1. So that's going to be 10 minus 6 over 3 minus 1. So that's 4 over 2. So we know so far our slope is 2. And we can solve for the b by putting in, well, let's just put in 1/6. So 6 equals 2 times 1 plus b, so b is 4. So I have my equation, y equals 2x plus 4. I'm putting 5 in for x. So y equals 2 times 5 plus 4. 10 plus 4 is 14, and that's what goes in there. So that makes sense? Good, Dominic. That was a good workout with slope. Logan, you're good? Yes. Okay, let's go on to the next one. This is a little tricky. I try to give you every possible thing you might see on test day. The function g is defined by g of x equals 2 absolute value of x minus 2 for all of x. Which of the following is equal to g of a minus 1? So if I put in a minus 1, what am I going to get out? 2 minus 1 minus 2 absolute value. That's 2 times minus 3, which is 2 times 3, which is 6. And I might be tempted to go to D, but that's a trap. Because I have to try all these. So let's put in G of 3. That's going to be 2 times 1, which is 3, and that's not 6, so that doesn't work.
2, right? 2 times 1 is 2.
Yeah, I'm sorry. Yeah. So if I put in a 3 there, 2 times 1 is 2. So that doesn't equal a 6. If I put G of 4 in, I'm going to get 2 times 4 minus 2. 2 times 2 is 4. That does not equal 6. If I try G of 5, I'll get 2, 5 minus 2, and that's 2 times 3. So the answer actually will be C. Does that make sense? Take a minute. Dominic's nodding. Logan, are you good with that one? Okay, this is just going over the graph things. So, you know this already. If it's increasing, it goes from left to right this way. Decreasing is this way. And I've given you my little thing about the x-intercept. That's where y is 0, and the y-intercept is where x is 0. That's our little clue sheet. The solution is where they cross. So you can have a maximum point if you have an upward parabola. No, you can have a maximum point if you have a downward parabola, and you can have a minimum point. So this would be a minimum, and this would be the max. So let's look at an example. We'll do some graphs. The figure above represents a portion of the function f. Which of the following represents all of the values between -4 and 4 for which f is increasing? Well, it's only increasing right here, right? So that will be between a -1 and 2. And so that answer will be B. So transformations and translations is when you move the graph. So let's go on to the next page. Now this is where it's a little tricky. As you remember, if it's an upwards parabola, it's a happy day. Now, when it's a -2, we move it 2 to the right. Do you remember that crazy? It's counterintuitive. Thank you.
Gotta get it. So
Yeah, thank you. And when it's a +2, you move it 2 to the left. So that makes sense. I just wanted to review that. Oh, thank you. And so the vertical translations are easy. This is a normal one. If it goes up 2, you just take the y value up 2. Yeah, move the people. And if it's a -2, we move it down 2, right? That makes sense. Okay. So there's reflections across the x-axis, which is like a mirror, and we haven't seen any reflections across y, so we won't do that one. Let's try a book problem, just so we're keeping in touch with the book. So if we have page 479, and we're going to number 14. Okay. I'm not going to draw the graph, but you can sort of see it's a whole page. The graph of the rational function f is shown where y equals f of x and x is greater than or equal to 0. Which of the following is the graph of y equals f of x plus 5? So I want to move this whole graph up 5. Does everybody see that? So, like right now, 10 is at a plus 1. But if we move it up 5, does everybody see it's going to move to D? Does that make sense? Julie's nodding her head, so is Logan. Dominic, are you good with that one? Not really. Oh, you are good. So we just had to move it up 5. So that made it D. And another good bit of news is on the next page of the packet. Thankfully, they don't have any horizontal stretches or compressions, so you don't have to worry about this. So this whole page is off the test. You won't see it. I love telling you what you won't see. Okay, so
Do you
now,
want to do that, moving the problem one, this one,
not really.
that one?
Do you want to do it?
Yeah, let's just do it.
What?
It's, this one. It's 8:35, it's not hard.
It is hard. Okay, Jimmy wants to push me here, guys.
No, it's not bad.
So we want to do page 835. What is it, number?
Number 22.
22, hardest one.
There's just like a fast and a slow way of doing this one. And I just wanted to make sure that they know how to do it the fast way.
Okay. All right. All's fair. Let's try 835, number 1.
22.
Or 22, I'm sorry. Okay, so this is the hardest one. 835. Number 1.
22.
22, yeah. So we're given this equation, f of x equals 4x squared plus 64x plus 262, right?
4x squared plus 64x plus 262.
Good.
Okay, so now they say the g function is g of x equals f the quantity x plus 5.
So we might want to move this whole thing to the left 5, which
Right. But here's what I wanted to tell them, or just or maybe remind, or I don't know, explain. We could put x plus 5 using substitution. We could put that in for x in our entire f function,
right.
and we can figure out what the g function is. But it is going to be much faster to just figure out the where the vertex was in f of x, and then just move that
Oh,
5.
yes.
Move that 5 to the left.
Okay, so the vertex is good. We're
Just
good.
find the vertex of the f function and then move it 5 because
the
we don't even need the g function. That's a
Right.
huge waste of time.
Yeah, so we just do the vertex is minus b over 2a. good review of that. You could put it in Desmos, I guess, but these numbers are pretty high.
Yeah, if you type it into Desmos, you should be able to click it and
Yeah.
get the vertex.
So this would be minus 64 over 8, which is a negative 8.
Okay, now we just have to move that to the left 5.
To the left 5. And so that hard one would be a negative 13. The hardest one.
And you did it in like seconds. But
Yeah,
like they're trying to make you put x plus 5 in for all of these x's, and that would take forever. It would work.
yeah.
It's just a huge waste of time.
Does that make sense, Logan, to you? Okay, Julia, good. Dominic, what about it? Should I do it again? Oh, you're good. Okay, and that was a hard one. Thanks, Jim.
Yeah.
It wasn't so bad. I was thinking because you came up with that. It's good. Okay, back to the packet. Okay, this number 1 is a little tricky, and I'll show you why. We only have one more class, guys. You realize that? And you're taking the test on Pi Day, 3.14. I don't know if that's an omen or not. So the complete graph of the function f is shown in the xy coordinate plane above. For what value of x is the f of x at its minimum? But see, we want x. So does everybody see how A could be a trap answer? They always like to put the trap answers in A because you would want to think, oh, it's -1. That's the lowest point. But we want the value of x, which is actually going to be 2. Does everybody see how they were trying to trick you? Good. They're nasty. Okay. Okay, this one isn't too bad. We want one like this. So for number 2, it says a system of 3 equations and their graphs in the xy coordinate plane are shown above. How many solutions? So we have a circle, a parabola, and a line, but it has to cross all 3. So it's 1 here and 1 here. This one does not count because it's only 2. So this one would have an answer of 2. So let's try a book one, and we want one of these for sure. So we're going to go to 246, number 5. So we have something that looks like this. Parabola in a line. So how many solutions would you think? Julia, just shut it out. How many solutions? It would just be 1,
2.
2. Good job. So that would be C2. We want one of those because we knocked that out of the park really fast, right? Okay. So let's go on to the next page of these diagrams in the packet. Hang in, this is the home stretch. You don't give up in the race at the home stretch. We just have this week and next week. And I probably won't see you again, but if you could be nice enough to tell me how you did or anything, we would love to know. Okay, so let's go on to the next page. This one's a little tricky. You have to sort of think backwards. The graph of function x minus 3 minus 4 is shown above. We want to get f of x is 5. So if we go to this point, 3 over 1 up. Okay, we want to undo what we did. So instead of going -4, we're going to go up 4. And instead of going -3, we're going to the left 3. And so f of x has to be 5 at 0. Does that sort of make sense? Undoing. I don't know if they would give you one this hard, but you have to, we were trying to over prepare you actually. Okay, so now the next one, the figure above shows the graph of the function f. Based on the graph, which of the following could be true about the function over the entire interval? Well, there's no line down here, so these are open circles. So we're not going to include A or B because there's no, if we had a line underneath, we would, but we don't have it. So I just want to go over that fun fact. So here is f in this space, is f of a always over the increasing? No, it's not decreasing only in this part, it's only increasing that part. It has one maximum point, which would be up here. So that makes sense. Nodding heads, good. Okay, let's go on to this one. The graph of the function f is shown in the xy coordinate plane above. What is the maximum value of f of x for this interval? Now here, what could sort of confound us is this graph up here. So if this is 2, this would be 4, and that would be 6. So really, f of x, they want you to say, oh, it would just be 3, but it's going to be 4. Does everybody see why? Because you have to study the increments on the left. They could catch you with something like that. Okay, the elephant problem. Let's look at number 6. The graph of f of x is shown above. So we're going for this whole thing. How many? So this is really y equals 3. So if we just put y is 3 across this whole thing, there will be 2 solutions. Does that make sense? So now, whoa. Does that make sense that there's only 2 solutions there? Nodding heads, thumbs up. Okay. So if you see something like this, you just draw the line and you'll see how many solutions there are. Okay, so on the next page, we have 2 more of these. Number 7. The graph of the function f is shown above. The function g is, we're taking this down 4. So if we take this down 4, we're going to be somewhere like this. Jacob, yay. So you can review this if you need to, but we're on page 14 in the functions packet. We'll let you get up to speed here.
Hello? Hello?
Earths. Functions.
Nobody?
Sorry, you can keep going. I'm just finding my functions packet.
Well, that's okay. We can wait for you.
You're on page 14?
Yeah. We're on page 14, but we used to find his packet. It should be in there, I hope. You got it! Yay! Okay, so on page 14. Okay. The graph of the function f is shown above. The function g is defined. We're taking this function down 4. And so -4 and 4 will work, but they only give us 4, so that answer would be 4. Make sense? Okay, so let's go down to the next one. Now this is they want to intimidate you by putting this here. F of x, it's a quartic function, is that how you say? Is graphed in the xy plane. It has 4 solutions. So let's try at y equals -2. Does this cross 4 times? Yes, 1, 2, 3, 4. y is 1, that's only going to cross at 2 points, so that's out. 2 is only 2 points, so that's out. And at 3, it's only 2 points. So the only one that has 4 solutions is a -2. Does that make sense? Jacob, we can't see your smiling face. There you are. Okay, let's try a book problem with this. I'm going to throw you to the wolves and let you try it. Okay, so we're going to go to page 241, number 14. I'm just going to sketch this. We have this little W thing. It says, sort of like the one we just did, the function f of x is graphed in the xy plane. If x is a constant, we have 4 solutions. So let's try what we just tried. Would 1 give us 4 solutions? No, right? It only gives us 2. And I know Jimmy will say they want distinct.
Yeah, if you put in 0, you don't get 4 distinct solutions. You do get 4 solutions, but
Yeah, it's 0. We get 4 solutions, but they're not.
2 of them are 0.
2 of them are 0.
Right.
So Jimmy's right. This problem should have the word distinct. But try to beat me to the answer. At -1, that will work, right? Everybody see that at -1, 1, 2, 3, 4. So I don't know if you had problems like this in your math class, but now if you get one of these, it'll be easy. So everybody's good with that kind of a problem? Okay, good. All right, next page. Zeros of a function. We lost Logan to the SAT monsters again, Jacob. I don't know. Okay, don't quit in the home stretch. I'm preaching to the choir because you all are here. Okay, so let's go to the functions. So here, if the graph of a function intersects at the x-axis at specific points, so here pretty easily we can see this will be the one that has the x-intercepts right in the graph. So that will be C. Okay, so let's try a couple in the book. Okay, so we're going to go to 240, number 13. The graph of which of the following functions in the xy plane has x-intercepts at -4 and 5. And so if those are the x-intercepts, that means we need x plus 4 and x minus 5, which would be answer choice A. So that makes sense. And let's go to the next, let's just go to 242. And we're looking at the reservoir question number 16. For a certain reservoir, the function f gives the water level f of n to the nearest whole percent of capacity on the nth day of 2016. Which of the following is the best interpretation? So I want you to read through those choices and pick out an answer. So what they give us is f of 37 is 70. So read through A, B, C, D. And so we want C, right? On the 37th day, the water level will be at 70% capacity. Does that make sense? Good. Just wanted to do a verbal problem there. Okay, back in the function packet. And so for you, Jacob, there's like 8 questions on functions on the test. So for this one, the graph of which of the following functions in the xy plane has x-intercepts at -2 and 4. So that would be x plus 2 and x minus 4, which occurs in answer choice C. Thank you, College Board, for 10 points. So on the next page, okay, a polynomial has zeros at -9, 2, and 0. So that means we're going to have x plus 9, x minus 2, and just an x out front here. So when we FOIL this, we're going to get x squared plus 7x minus 18, but then we have to multiply the whole thing by the x, which is at 0. And so that'll give us x cubed plus 7x squared minus 18x. And that's going to be answer choice B. So that makes sense? Everybody, okay. This one. The function f is defined by a polynomial. Some values of x and f of x are shown above. Which of the following must be a factor of f of x? So it's gotta be x minus 3, because if I put in a 3, I'll get out 0. Does that make sense? Can you explain it any better than
Yeah.
that?
The factor would be at the 0, and I like your explanation.
Okay, all right. It makes sense, Jacob, Dominic, sort of, Julia. Thanks for staying with me, guys. Okay, here we have x-intercepts at -4, -2, and 2. So that would be x plus 4, x plus 2, and an x minus 2, which would be D. That'd probably be like a middle question. Okay, the next page, number 5. We've already done 17 pages. Wow. In an hour. The function f is defined by 2x cubed plus x squared plus cx plus 6 is 0, where c is a constant. So let's not do a fraction or a variable. Let's put -3 in for x and see what comes out as c. So if we put a -3 in here, and you can try to beat me to the answer. So that'll be 2 times the -27 plus 9 minus 3c plus 6 is 0. So moving on, we're going to have -54 plus 15, because 9 and 6 is 15, minus 3c equals 0. So that's going to be a -39, adding 3c to the other side. So c has to be a -13. Does that make sense? Julie's nodding, Dominic's nodding, Jacob's nodding. Okay, number 6 is pretty easy. The figure above shows the graph of f of x. What's one value of x for which x equals 0? Well, x would equal 0 at 4 or a -2, but the only thing we have here is a 4, so that's what we have to pick. Okay, on we go. We want one like this. Remember, we had one of these at the orientation. This is easy. So if the function f has 5 different zeros, which of the following could represent the complete graph? Well, this one only has 3. This one has 4. Whoa. This one has 3, but this is our winner. 1, 2, 3, 4, 5. So that will be a slam dunk, right? We want one of those because then you have more time for the harder problems. Now, I hope you've seen nested functions. Like, have you seen f of g of 1? We're putting 1 into the g function first, and then whatever we get out of that, we put in the f. Have you seen this? Just raise your hand if you've seen this before. Dominic, you've seen this? Good. Okay, so this can be on the test. So we put 1 into the g function. That gives us 7. So now we need f of 7 is 4 times 7, which will be 28. Not so bad. Okay, this one, a little weird. A function f satisfies when we put in 3, we should get out a 2. When we put in a 6, we should get out a 4. G of 2, move the people, is a 3. What is the value? So we want G of 3 first. So that's a 6. And then we want F of 6. And that's a 4. So that's going to be answer choice C. Okay. Sorry, I know I,
I just want to make sure you can get your brushes.
yeah, thank you.
Mhm.
Number 2. Some values of the function f and g are shown in the table above. For what value of x does f of x equal g of x plus 3x? Well, let's try the values. So if we try A, if I try -2, I'm going to get 3. Does 3 equal g of x, which is 3, plus 3 times a -2? Does 3 equal a -3? No. So that's out. So then I'm going to try -1. So we'll see if that works. So f of a -1 would equal g of x, which is 4, plus 3 times a -1. So f of a -1 is 1 right here. I'm just looking at this line. So 1 equals 4 minus 3. So that's our winner, which is B. Okay, we'll try another one down here, and then we'll try a couple book problems. So try to beat me to the answer to this one. So we have f of x equals 3x plus 3. We're going to put 3 into the g function, see what we get out. That's going to be 8. Then we put 8 into the f function, and 3 times 24 plus 3 will get us 27. That makes sense? Nodding heads. Good. Okay, we'll try this bottom one, and then we'll try some book problems. Oh, no, we won't. We're going to go right to some book problems. Okay, so I want to try 613, number 7. Okay, this one's a little. Okay, go ahead. You're avoiding the SAT monsters. Yes, that was parents with something. He says, I'm going to avoid the monsters. Yeah, they'll come and take you away for sure. It's just apathy. So I'm going to go back to my slope formula. So we have 28, 15, 26, 22. So if we do 22 minus 15 over 26 minus 28, we're going to get -7/2. So we know now that A and B are out, right? So now we have to get the B because we don't know what that is. So I'm just going to pick this equation. It doesn't really matter. So we're going to have the we have y equals -7/2 x plus b. And I'm going to put in 26 for x. And I'll get out 22 for y. So then that'll be 13, which is going to be minus 91 plus b. So b has to be 113. And so the answer, we're in the higher difficulty module here, is going to be D. So Julia, do you see it? Can you give me, good. Dominic, take a minute. Do you want me to go over it again? Or are you good? Give me a thumbs up if it's good. Okay, that was a good review of the slope formula. It comes in all kinds of sizes. And then let's try 731, number 4. I don't think I have the right number there.
This one?
Oh yeah, the table. Thank you. So we have x and f of x,
G of X.
or g of x, I'm sorry. And so if we put in a -1, we'll get out of 25. 0, we would get out a 1. 1, we would get out a 1 over 25. 2, we would get out 1 over 625. So let's try all the answers. So -25 to the 0 power would just be 1, so A is out. B, if we put in 0 for x, we would get out a -1. C wouldn't work because we would get 25 where x is 1. We would not get 1 over 25. How many C? It's going to be D. Because, let me write it out. So we'll have 1 over 25 times 1 over 25. And that's going to give me 1 over 625. Make sense, Julia? Yes. Dominic's good too. Oh, good. Okay, now the next page. Oh. These, you won't get anything this hard on the test. Wait a minute, I have everything up here like crazy.
Are you doing the packet or
Yeah,
are you doing the book?
I'm doing the packet. The problem always confuses me.
Oh,
Yeah. Okay, so we're gonna do different colors on this one. You will not get one this hard. Not on test this hard. But I'll just explain it. So if when I'm putting the function back into itself, that's what that means. So I'll have fourth root. Okay, Jacob, you wound up at a harrowing place. So, yes. So look at number 4. You won't get this one on page 20. So we're putting this function back into itself. So this will be, I loved his little grimace, x to the 4 plus 1. And so now,
okay. So now she's just gonna put everything that was originally around X around this. So a fourth root, an X to the fourth, and or a fourth power and a plus 1. Yep. A fourth power 2.
where?
Right here.
Okay.
Sorry. I'm just trying to write with my other hand.
Okay.
That's supposed to be a 4. Can you fix that? That's supposed to be a 4.
Yeah. So this is all my x. And
That was
so,
a parenthesis and a 4. Yeah.
yeah.
Okay. So now the fourth root and the fourth power cancel with, but no, not that one. We need that
Oh,
one.
this one can.
Yeah, that one cancels with the fourth power I just put in.
Yeah.
And you should be able to get the answer.
So this will be x to the 4th plus 2. And if you
Yeah.
don't see this, I still don't see it. I've done it 75 times easily. Does anybody see this problem? Maybe,
We purposely try to make this page a little harder. Our logic was if you can handle any question on this page, the SAT is going to seem like a piece of cake
but not to worry.
because these are like ramped up a little
Yeah,
bit. Like even these next two are kind of
yeah.
up there.
So don't worry about if you don't see it. Okay, we're just, yeah. So f of x is 2x plus 4. So we're going to put this in for x. So we'll have g of 2x plus 4 equals 2x plus 4 times 2x plus 4, because I have to square it, minus 3,
I
2x.
can move them.
Yeah. Thank you. Minus 3, 2x plus 4. So then I will just FOIL this, and I will get 4x squared plus 8x plus 8x is 16x. Then I have to just,
Plus 16.
yeah, plus 16, thank you.
Mhm.
Then I have to distribute this -3. I was jumping ahead of myself. So that'll be minus 6x minus 12. So that's 4x squared. 16x minus 6x is 10x. 16 minus 12 is 4. So the answer for this one
It's a.
is A. Oh, good. Everybody's good with it. Okay, this last one is also very hard. I mean, it's just strengthening your math ability.
But if you can handle this, the SAT is going to be like a joke. I know
It's
it's not
not
a
a
joke.
joke,
I know
it's
it's not a
not a
joke,
joke.
but this is harder than the SAT. That's what I was
Yeah,
trying to say.
yeah. So
Intentionally.
we're going to put 2 into the g function. So that's just going to give us 6, right? So now we're putting 6 into the h function. But problem, we have g of 6, so we have to put this 6 back into the g function. So 6 squared plus 6, 36, so that'll give us 42 plus 24. 2 times 36 is 72. And we should get out 138. And that was a real hard one. Does that make sense? Sort of. Nodding head, Julie, Dominic, sort of okay. Good. I mean, any way we're strengthening your brain is good. So let's go on. Graphs of composite functions. So this one's not so bad. The graphs of the functions, f is up here, g is down here, between -4 and 4. If f of a -2 is a, so f of a -2 is going to be 3, right? So now we want g of 3, which will be 1, 2, 3, 4. So it's going to be a -4. Make sense? Good. So on the next page, we have another one of these, or some examples we're going to try. So in this case, the graph of the linear functions f and g are shown in the xy coordinate plane. For what value of x does f of x equal g of 4? So we want to see what g of 4 is. So g of 4 is just going to be 2. And I could put it in the equation, and nice to give us, and I'll get 2. So now I want f of x to be 2. So I put 2 in there because it's going to be pretty hard to read that off the graph exactly. But I divide both sides by 3, and so x is 2/3. Thank you, College Board, for 10 points. Good job on that one? Okay, good. Okay, this one's easy. A portion of the graph of the function f is shown in the xy coordinate plane. What's the y-intercept? So the y-intercept is here is 2. If I move it 1 up, the y-intercept will just be 3. So we'd like to give you some easy ones along the way. Good. 22 pages already. Woo! So break is fast approaching. Which of the following could be true? Well, if we take f of x and move it up 4, we're going to have something up here. So we know a and b are not right. But is f of x up 4? Yes. And then we have to see, did we move g of x? We moved it to the, 1, 2, 3, 4, 5 to the right. So 5 to the right
And up 4.
and up 4 is going to be C, right?
Yeah.
It's just that that little thing is confusing. When it's a negative, it actually moves it to the right. I almost just have to memorize that. This one's easy. Okay. The graphs of functions f and g are shown above. Which of the following best approximates f of g of 0? Well, g is the curve function. So g of 0 is 7. And so f of 7, I'll spare you counting it all up. It's 10. Woo. Good workout tonight. You can show your parents this and maybe they'll ask for a reward. The graph of y equals, we did one of these at the orientation. If we're making it absolute value, we know everything has to go up to quadrants 1 and 2. And so we will have So hard. We'll have three pointy mountains and two round mountains, which is C. That makes sense? You can feel very accomplished after you finish this packet. And this next one, the graph of F is shown above. So we want to make it downward. So it's like a mirror function because they can flip it across the X, but not across the Y. So this will be down 2, but then we're moving it up 4, and so it will be answer choice C. I'll let you take a minute to digest that and just give me a thumbs up if it's good. Good, Julia. Dominic, good. Jake, good. Okay, let's try one book one. And then we're going to go into something else, thank goodness. Page 731, number 9. Well, this one's hard. But you have a way of showing me how to do this.
Yeah, I have a strategy for this.
Okay, so Jim has a strategy for this one. So it's module 2, hard one. F of x is x squared plus 6x. G of x is 9x squared minus 27x. Our job, oh wait, I'm not going to get, so we know f of x times g of x. So what will we do here?
Okay, so that's a b, right? Bx.
Yeah, that's a bx, sorry.
9x squared minus 27x. Okay. So they tell us that f of x times g of x is 9x to the fourth minus 26x cubed minus 3x squared. The trick for this one is to realize that we only need to worry about the bx times the minus 27x. That's going to equal negative 3x squared. And you don't have to multiply these all by each other. It's like a waste of time.
Okay, so it's not
Yeah, let me explain that again. This times that is going to equal negative 3x squared.
bx times,
Bx times negative 27x
that's the only way we're going to
is
get
going to equal negative 3x squared.
it. You see that? Okay, now take a second, see if that makes sense. Because I want to get this number, and the only way
Yeah,
I,
negative 3x squared. Where did you get that b? Okay, yeah. So all I was saying is this, like here, that times this is going to equal this.
okay. So this times this,
You didn't finish writing this out, but it's the last term in that. After the 26x cubed, there's a minus 3x squared.
okay. In here, in the
Yeah,
actual,
Yeah,
okay.
I think that's the issue. That's a minus 3x squared. Okay, so yeah, the bx times the negative 27x should just give us the negative 3x squared. And we don't have to mess with all the other, because we don't care about anything to the fourth power.
Okay,
or
so
anything to the third
bx
power.
times the minus 27x is going to equal
Negative 3x squared.
negative 3x squared.
Yeah, we don't care about the fourth powers. We don't care about the third powers. Just look at the x squared ones, because that's all we really
So
need.
we want to get the b, which will be, so we can
Just
be,
solve for b, yeah.
yeah. So we divide everything by x.
Well, by x squared, right? Because you had negative 3x squared. You have negative 27bx squared. No? So bx times negative 27x is negative 27bx squared.
Yeah, okay. Negative 27 bx squared.
Yeah, so negative 27bx squared equals negative 3x squared.
Okay. I'm starting to see it. It's a hard one.
Yeah,
So
negative 27 bx squared equals negative 3x squared. Okay, so divide both sides by x squared.
yeah,
Gives you some more space.
yeah. So I'm going to have negative 27b equals minus 3. Divide by a minus 27. And so b is going to be minus 1/9.
How did you get a minus?
Oh, wait, how did I get a minus? Plus 1/9.
Yeah,
And so that answer is C. Okay, I had a little bit of trouble seeing that.
yeah. I think the hardest part about this one is they're trying to make you mess with the fourth powers and the third powers, but we don't even need to.
Yeah, we're just focusing on the x squared. Okay, Jacob, does that make sense to you? Good. Julia, thumbs up. Oh, Dominic, good. See, Mrs. Hesser was struggling the most on that one.
Okay.
Okay,
Well, you are in the higher difficulty module too. This is what would happen if you're doing really well on the test.
yeah,
They
you
give
want,
you harder ones.
yeah, you want to get harder ones. Okay, so now we're into our final thing here, exponential functions. So we're going to have a break when this packet's done. So this is pretty simple, except for they can give you all kinds of problems. So linear growth, you just add every time and you get the line, right? So let's go to an easy one. 262, number 8. Oh, Logan, you're back. Jacob's always worried that the math or the SAT monsters got you. So we're on 262, number 8. This is the hard part, so I'm glad you're back. Okay, pretty easy. Every month, Jamal adds 2 new books to the library. So if it's a plus 2, plus 2, plus 2, it's going to be A, increasing linear, right? Everybody see that? It's pretty easy. Okay, now the exponential one. So I'm going to move everybody over here. Is where you have a common factor. Do you see that? And it goes up amazingly fast. So if we look at the cell phone problem, I'm going to move you back here. All the way in Connecticut, I could just push you, Jacob. Sorry. I never thought this technology would exist in my lifetime. That's why I'm amazed by it. There's probably nothing that's going to amaze you guys. So you see here we're going up 100. Here we're going up 150. And here we're going up 225. So it's not linear. So let's look at the answer choices. Then we'll try some in the book. The function's not linear. So we know that's not true. Is it exponential? Because they increase by the same factor? Yes. So it's C. Does that make sense for everybody? Okay, good. So this one, diamond prices are projected to rise an average of approximately 6% each year. What kind of function could be used to model the demand in diamond prices over the next several years? So if it's going up 6% every year, it's going to be an exponential function. Okay, carbon dioxide emissions, and these are the actual figures, are measured globally in billion metric tons. In 2000, the emissions were 25 billion. So that's what we're anchored in, 25 right there. It's going up 3.4%. Remember from the percent lesson, we drop the percent, make the little but. And so we're going to have 0.034. But do you see, this is going to be a trap because this will only give us the increase. This is what I want everybody to see right now. This is only going to give us the increase. We want all the CO2 in the atmosphere. So does it make sense that we have to multiply this whole thing by 100%? So the answer for this one would be D. Let's see if everybody's got that. Do you see why we have to multiply by the 1? Logan, does that make sense to you? Julia, to you too. Dominic, you too. Good. Okay, we're not going to do the car one. We're going to try some book ones. We don't have to do this. They first they said we would be doing compounded, but we're not doing this. So let's go to some book ones so we can really get into this. It's our last thing to conquer. So our first one will be on 478, number 13. Okay, we're looking at number 13. Well, no, 14. No, 13.
Yeah, you did 14 already.
Okay, this one. So f of t, see if you can beat me to the answer. 500 times 0.05.
0.5.
Oh, 0.5, sorry. Misread it. Times t over 12.
Raised to the power.
Yeah, raised to the power t over 12. So the function f models the intensity of an X-ray beam in numbers of particles in the X-ray beam, t millimeters below the surface. So at the surface, the time is going to be 0, right?
Or the
The
distance?
distance
Yeah.
is going to be 0. According to the model, what is the estimated number of particles in the X-ray beam when it's at the surface? So when it's at the surface, we need the t to be a 0, right?
Yeah.
And so anything to the 0 power is 1. And so we will get, it's only 500 number of particles. So that one's A. Does that make sense? Good. Some of these are a little confusing. Okay, so that was 478, number 13. So let's try, I'm going to try a couple more of these because they get tricky. 599, number 8. I'm pretty much guaranteeing you're going to get one of these on the test. Okay, a function P estimates that there were 2,000 animals in a population in 1998. Each year from 1998 to 2010, the function estimates that the number of animals in the population are going up 3%. The previous year. Which equations defines the function? Okay, so pick an answer. We know we're starting off with 2,000, which they all have. We know we're going up 3%. Do we have to put the 1 there? Yes. So it's going to be 1.03 to the x. Answer choice C. So does that one make sense to everybody? Good. Good, good, good. Okay, now we're going to try a couple more. 360, number 17. Pretty easy. So lock in an answer. The population of City A increases 7% every year from 2015 to 2016. If it's K times the population, what's the value of K? So lock in an answer. It should be C 1.07. Does that make sense to everybody? Oh, good. Yay. Okay, we'll try another one. 720, number 17. So I can, like I said, you're pretty much going to get one of these on both your modules somewhere. So 720. Number 17. The function f of t, it's 40,000. We're doubling it, t over 790. Gives the number of bacteria in a population t minutes after initial observation. How many minutes does it take for the number of bacteria in the population to double? Well, I want this value to be a 1. Does that make sense? Because then it will double. This is the rate. It will double.
That's the 200%. That's the doubling, right?
Yeah, that's the doubling right there. So I need that answer to be B 790. Because then that'll change this to a 1. And so I will get double. Is that how many?
You'll get 80,000.
I'll get 80,000 bacteria. Does that make sense, Logan? Good job. Jacob, Dominic, makes sense? And Julia, okay. Okay, that was 721. So 8:45, number 8. We're almost done, guys, to the break. Okay, this one's a little different. For the function q, it's decreasing. Now think about this. It's decreasing by 45%. So that means it's only going to be 55% of it was originally. And so that means it's going to be answer choice C. Does that make sense? Because we start with our 14 and we only want 0.55 because that'll give us a decrease of 45%. So if I give you a decrease, does that make sense?
You can even also just put in 0 for X and then look at answer choices A and B. They're not going to give you 14.
Right.
You know what I mean? So you can eliminate the
Yeah.
answer choices right away as well,
Yeah.
which is
Just-
nice.
yeah.
I always try to
Put in 0.
Yeah, X.
Yeah, try 0. That always helps. And then the last one, I'm going to have Jim explain. 1077, number 9. He's hung in there, guys. And it all is going to pay on test day. 1077. Number 9. And this is high difficulty. They've been making these a little harder. So you want the screen?
Okay.
Yeah.
Okay. All right. So we're gonna do this one. All right. So they give us the formula. They give us this. P equals C times 2 to the RT. Okay. So this is always your rate. Okay, let me read the experiment. It says a scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria. So the bacteria have doubled in 4 hours. Assuming exponential growth, the formula P equals C times 2 to the RT gives the number of bacteria in the growth medium, where R and C are constants, and P is the number of bacteria T hours after the initial measurement. What is the value of R? Okay, so that 2 is always your rate. In this case, it's 200%. That's where the doubling is happening. And you should know that the 12,000 goes here. But what if you forgot? We can derive it. And how do we do that? We say P, this would be 12,000 equals C times 2 to the R times 0. I just put in 0 for T. So this is now 2 to the 0, which is 1. So C is 12,000. So you should know that the C is supposed to be 12,000, but if you totally forgot, you could still figure out that the 12,000 goes in for C. So that's step 1. All right, so we have our formula P equals 12,000 times 2 to the RT. All right, so we have the formula now. Now we just have to put in the doubling situation. So 4 hours later, the bacteria have doubled. So now it's this. This is still 12,000. This is still 2. And this is now R times 4. 4 hours. Okay. Everyone's good that far? Now I divide both sides by 12,000. Okay. And we get this. 2 equals 2 to the R times 4. Well, this 2 is really 2 to the first. So we don't even need the 2's anymore. 1 equals 4R. R equals a fourth.
So see if they
So
want,
it's B.
see if they understand it, because you might have to go over it.
The last step is just the exponent rule. So once I have a like base, I don't need the base anymore. And yeah, that was a hard one.
How many?
Any questions? Is
See if they see it.
everyone good with it? Anyone good with it? How about we start with that? That sort of makes sense. That we're in the higher difficulty module, but if we want to solve for exponents, we can't until we get like bases because I mean, barring some kind of using logarithms or something, yeah. Okay. So that was that one. Oh, okay. All right. So Mrs. Hessler said it's break time. So let me just write down that we're on a break. Break. And we'll be back. Let me just tell you when we'll be back. We'll be back. Let's take a 10-minute break. We'll be back at 7:21. Okay, so it's 7:21, so we should be back. Is anybody back? We're doing expression of ideas. Julie's back. Jacob's back. We're just going to do this packet today. Dominic's back. And Logan's back. Okay, so just find your expression of ideas packet. We're just going to go over rhetorical synthesis and transitions today. Okay. So yeah, this is 20% of the test. So this is just that last little bit of the English we've yet to cover. So we'll start with rhetorical synthesis. These are the student notes questions. They'll say the student took the following notes. They'll give you a bulleted list of 5 bullet points. They always tell you what the student is trying to do with the notes. They always give you the student's goal. And then they ask you which answer choice um, will achieve the student's goal. So it's really just a test of relevance versus irrelevance. Because whatever the student is trying to do is it's always a very specific thing. So you will never utilize all of the bullet points. It's just not going to happen. The right answer will never be a combination of all 5 of the bullet points. You typically just have to pick and choose some information from the bulleted list that will achieve what the student is trying to do. Oh, the other thing I wanted to mention, we can assume that the bullet points are all factually correct. When they give you a bulleted list, it's all from a reputable source, a peer-reviewed source or whatever, so we can trust the information. They're not trying to trick us. I mean, they're trying to trick you, but they're not trying to trick you as far as the validity of the information. Okay, so relevant information will be useful and necessary to achieving the writer's goal. Irrelevant information, we're just going to leave out that information from that bullet point. So as you work through the incorrect answer choices, you will notice incorrect answer choices often contain minutia. These are just smaller, trifling matters. Certain information tangentially related to the topic is not pertinent to the student's task. Yeah, the correct answer choice will not combine all 5, bullets. All right, so let's take a look at an example. All right, here's our example. Okay, so these are all over the test. You'll notice these student notes questions. They always start like this: while researching a topic, a student has taken the following notes. Then we have our bulleted list. These are all factually true, and they always tell you what the student is trying to do with the information. I like to underline it, and when you're taking a test on Blue Book, the software permits you to underline or highlight portions of the question, particularly useful for this type of question. I just want to underline what the student is trying to do because this is going to like they almost this type of question almost solves itself after we do this. The student wants to indicate that Lessons of the Hour by Sir Isaac Julian contains a mixture of period reenactment as well as contemporary video footage. So we only need an answer choice that discusses a mixture of period reenactment as well as contemporary video footage. So I'm going to go through the bullets real quickly, and let's just see if we need that particular bullet. Here's the first bullet. Sir Isaac Julian, born 21st February 1960, is a British installation artist, filmmaker, and art professor at the University of California, Santa Cruz. Julian's art installation, Lessons of the Hour, utilizes video from period reenactments. So we might need that. We're looking for that on 5 screens to portray content from the life and lectures of escaped slave and abolitionist Frederick Douglass. Lessons of the Hour contains excerpts from Douglass's key speeches, Lessons of the Hour, What to the Slave is the 4th of July, and Lecture on Pictures. Interposed between the period reenactments, we are looking for period reenactment. Lessons of the Hour includes footage of present-day Baltimore. Well, we definitely needed that part. That's the contemporary video footage that we were looking for in the student's goal. So Baltimore is the city in which Douglas was enslaved and from where he escaped in 1838. Here's my last bullet point. Lessons of the hour includes a reenactment. We are kind of looking for period reenactment. It includes a reenactment of African American photographer J.P. Ball making a portrait of Douglas. Okay, so the student wants to indicate that Lessons of the Hour contains a mixture of period reenactment as well as contemporary video footage. Let's go through the answer choices and let's see which one has both. A says Sir Isaac Julian, a British installation artist, filmmaker, and art professor, created the art installation Lessons of the Hour to highlight lectures and scenes from abolitionist Frederick Douglass's life. So I don't have any period reenactment or contemporary video footage in A. Here's B. Lessons of the Hour includes a reenactment. We are looking for that of African American photographer J.P. Ball making a portrait of Douglas, as well as excerpts from Douglas's key speeches. So no mention of video footage in B. We can cross it off. C says Lessons of the Hour includes reenactments. We are looking for that. Of events from the life of abolitionist Frederick Douglass and excerpts from his key speeches, Lessons of the Hour, What to the Slave is the 4th of July, and Lecture on Pictures. So no contemporary video footage in C. Here's D. Lessons of the Hour includes period reenactments from the life and lectures of escaped slave and abolitionist Frederick Douglass, as well as modern video of the city of Baltimore. So answer choice D accomplished the student's goal. We have both the period reenactment as well as the contemporary video footage. So that's what I sort of meant by just underline the prompt. Always read the prompt first. And these are so specific. The student is always trying to do something very specific with the information. So once you've underlined what you're looking for, I think it becomes pretty easy to see which one contains everything that we need. I mean, obviously they make some of these harder than others. They do vary in difficulty. Okay, so I'm gonna have you guys try some of these. Try these three. Try the three student note questions, but underline. Take the time to underline what the student is trying to do, and they almost solve themselves once you underline what you need. So take a few minutes, try these three. We'll take four minutes or so, and then we'll go over them. All right, it's been about 4 minutes, so let's go over these three. We'll do some more from the book tonight as well, but just to warm us up, let's try three of these. All right. While researching a topic, a student has taken the following notes. Always look at the prompt first and underline what the student is trying to do. The student wants to explain the type of stellar object supernova 1987A created. All right, so I'm going to go through the bullet list. I'm going to see which bullet points we may need to explain what was created. Here's the first one. A supernova is when a star collapses to form a neutron star, a black hole, or a diffuse nebula. So it sounds like we may have three options here. On February 23rd, 1987, light from supernova 1987A reached Earth. Supernova 1987A was the closest supernova recorded in 400 years and was visible to the naked eye. Scientists have searched for the remnant of supernova 1987A to determine if it had created a black hole or a neutron star. Okay, so it already sounds like maybe we're down to two of those three. I'm going to keep going because I don't know yet. The James Webb Space Telescope detected ionizing photons that indicate supernova 1987A collapsed to form a neutron star and not a black hole. Okay, so we should have the answer now. It's not a black hole, so answer choice A is out. The right answer for this one will be C. The James Webb Space Telescope has detected evidence that indicates the supernova collapsed to form a neutron star. So not too bad. They're not still hypothesizing, and B didn't mention what was created. Okay, so yeah, once you underline what the student is trying to do, these things almost solve themselves. I think that's a good strategy for this type of question. All right, while researching a topic, a student has taken the following notes. Read the prompt first. The student wants to emphasize that the artwork contains material from national and native newspapers. All right, so I'm looking for a bullet point or bullet points plural that mention national and native newspapers. All right, Jean Quick to See Smith created state names in the year 2000 using oil, collage, and mixed media on canvas. State names displays a map of North America dripping with paint and the only place names present are those with indigenous sources. The indigenous derived Canadian, American, and Mexican place names are cut from newspaper clippings. Okay, so we got newspaper clippings. I am looking for that sort of. I'm going to keep going. State names contains clippings from newspapers such as the New York Times. That's a national paper. And Charcusta, that's a native newspaper. So we definitely need this bullet. Paint drips of various color encompass the entirety of the map with unlabeled land areas interspersed throughout the composition. All right. Answer choice A says state names contains a map of North America and the place names on the map are clipped from newspapers such as the New York Times, that's the national paper, and Charcusta, that's the native paper. So not too bad. That one was A. I like just underlining what I'm looking for because I think it makes these a lot easier because there's a lot of extraneous information. We don't care about the paint drips, I mean, this sounds like an interesting artwork, but once you kind of just hone in on what you need, I only need national and native newspapers. It makes these easier, I think. And then number three, all right, while researching a topic, a student has taken the following notes. Read what the student is trying to do first, underline that. The student wants to describe the Makisu's shape. So I only need the shape. A Makisu is a rolling mat that is an essential component for making sushi. The Makisu was first created in ancient Japan during the Nara period. The effective design of this bamboo rolling mat is a rectangular shape. I think that's all I need. All right, let's look at the answer choices. A Makisu or bamboo rolling mat is an essential culinary tool used to make sushi. No shape in A. The Makisu was created in Japan during the Nara period. No shape in B. C. The Makisu is a bamboo rolling mat which is formed in a rectangular shape. Right answer. So, I mean, I know that these vary in difficulty, but that one was a pretty easy one. Um, but that's the general strategy. Always underline the student's goal. It's always going to be something pretty specific. You'll never need all of the information. They're trying to overwhelm you with information. We just needed that one little thing. Um, okay, on to the next thing. All right, transitional words and phrases. All right, so this is the last thing we have to cover. We're going to talk about transitional words and phrases. They have a specific question. I'm going to skip ahead just to show you what the question always looks like. It always looks like this. Which choice completes the text with the most logical transition? They always tell you it's a transition question. So you know it's not a grammar question. The grammar questions always ask about the standards of conventional written English. And yeah, you'll immediately know it's a transition question. So you just have to come up with the best transition. I'm going to go over the 4 types of transitions that you will encounter in English. Okay. Most transitional words and phrases are additive, adversarial, causal, or sequential. So if they're additive, put a little plus sign here. They move us into the expected direction. No surprises. If they are adversarial, they subtract things, they move us into the opposite direction, an unexpected direction. And these vary in intensity. So adversarial transitions permit you to do a complete 180 if you need to, or I can make a slight concession. I can just subtract smaller information. We have causal transitions. We utilize these for cause and effect. So I could say if this happens, then that will happen. Any kind of causal situation can be expressed with like a logical transition. And then the last kind are sequential transitions. I'm gonna put like 1, 2, 3, 4. So we like to logically organize information in a sequence. Sometimes we might say first do this, next do that, finally do the third thing. So we can even use the adverb forms firstly, secondly, thirdly, but these are all common transitions in English. Let's look at the additive ones. All right, additive transitions add things, they move us into the expected direction. We use additive transitions to introduce information, show similarities, or add information. Okay, here are some additive transitions. Additionally, actually, indeed, further, moreover, for example, for instance, furthermore, in fact, in other words, in the meantime, let alone in addition, to illustrate regarding this, with regard to, similarly, likewise, namely, specifically, that is, and to be sure. So all of these transitions move us into the same direction. We're not doing anything strange. And we're just adding something, adding some additional information. Maybe I'm going to give you an example, and we could use something like for instance or for example, but we're just adding things. The adversarial transitions are different. They subtract things and they move us into the opposite direction. They allow us to do a complete 180 if we need to. But maybe I just want to make a small concession or illustrate a discrepancy. They all subtract things though. Some adversarial transitions are but, however, in or by contrast, although more importantly, nevertheless, nonetheless, despite, in spite of, regardless, rather, admittedly. So I could just admit something. I can make a small concession. Admittedly, in any case, after all, be that as it may, conversely, on the contrary, on the other hand, notwithstanding, and yet. So all of those transitions subtract things and they vary in intensity. I could do a complete 180. I could say, however, I could move completely the opposite direction with something like despite or however. Or I could just make a small concession. Nevertheless, admittedly, nonetheless. So those are all the adversarial transitions. The causal transitions are used for logic, for cause and effect. These are transitions such as because, due to, being that, in that, for, granting that, provided that, in that case, consequently, hence, so, for this or that reason, therefore, thus, accordingly, as a result, as such, and then. Okay, so I could say Socrates is a man, all men are mortal, therefore, Socrates is mortal. We can make a syllogism if we wanted to. We can, these are all for cause and effect. You can even say thus Socrates is mortal. Those are equivalent. Therefore means thus. Okay, those are all the causal transitions. We use that for logic. And then the sequential ones. 1, 2, 3, 4, 5, 6. We can use cardinal numbers if we need to, first, second, third. We just could sequence information in various ways. So first, second, third, or firstly, secondly, thirdly. Here are some beginning ones. To begin with, initially, at first, first of all, subsequently. I can add one. But the nice thing is, English permits me to go backwards. Previously, we can move around as necessary. Previously, after, afterwards, before, next, then, and then here are just a bunch of concluding ones. These I would expect to see at the end of the passage. To conclude, finally, eventually, lastly, in conclusion, altogether, in summary, in sum, to sum up, in short, and overall. So all of those transitions are just used to sequence information, and that's the last kind. So now we'll look at a transition question. Here is our sample transition question. All right, we immediately know it's a transition question. They always tell us. Materials on Earth are often encountered in one of three common phases of matter: gas, liquid, or solid. Blank, the triple point of a substance, refers to the temperature and pressure at which these three phases occur simultaneously. Okay. So my first sentence, materials on Earth are often encountered in one of three common phases of matter: gas, liquid, or solid. So if the next sentence were something like, yeah, and that's what we have on Earth, just things are just gases, liquids, or solids, I wouldn't need an adversarial transition to show me that this is surprising. It's surprising to me that all three phases can occur simultaneously. That sounds interesting and surprising. I need to indicate that with however. I'm going to read the whole thing with the correct transition. Materials on Earth are often encountered in one of three common phases of matter: gas, liquid, or solid. However, the triple point of a substance refers to the temperature and pressure at which these three phases occur simultaneously. All right, so that's the general idea here. That was an adversarial transition. I needed to move in the opposite direction. I needed the minus sign because this is unexpected. I wouldn't, after reading that first sentence, I would not expect that all three can happen at once, but they can. So that's why that one was B. All right. I will let you guys try the rest of these. So see if you can spot the correct transition. Try all five of them. We'll take a few minutes. We'll go over these five, and then we'll do some book ones. So give these ones a shot. All right, it's been about 5 minutes, so we'll go over these ones. All right, let's start with the first one. Just need to find the right transition. Amber is the fossilized resin of conifers, and the oldest sample dates to 320 million years ago. The resin first is formed as the tree produces a sticky substance that functions as a defense mechanism and heals the tree's wounds. The resin next transitions into a semi-solid. Blank, the resin darkens and solidifies into a solid structure. So the word first here was a sequential transition. The word next is a sequential transition. And the word finally is the third sequential transition. So we were just using sequential transitions for that one. First, next, finally. Not too bad. Let's try the next one. Non-Newtonian fluids flow like viscous fluids under low shear rates. Blank non-Newtonian fluids exhibit properties similar to solids under high shear rates. Okay, so if we're moving in the same direction, if we're just adding something with a little plus sign and an arrow, likewise, namely or similarly may work. An additive transition might make sense if the next sentence is expected. Is this surprising? Non-Newtonian fluids flow like viscous fluids under low shear rates. So if the next sentence says something like, yep, and that's how non-Newtonian fluids, they always pretty much just behave as fluids. That would not be surprising. They can act as solids. It's very surprising, right? However, non-Newtonian fluids exhibit properties similar to solids under high shear rates. So we are subtracting something. We are doing a complete 180. This is surprising information. So we can indicate that. So that's the best transition here. Anything unexpected, anytime we need to subtract something, we'll use an adversarial transition to move in the opposite direction. Here's number 3. The Svalbard Global Seed Vault was conceived by conservationists in the early 2000s who recognized the need for a global seed bank that could store and protect seeds in the event of natural calamities. The facility is located deep within the Arctic Circle and houses more than 1 million distinct seed types. Blank, the Svalbard Global Seed Vault, has played a role in supporting international scientific research. Okay, so they said that the original purpose of the seed vault was to store and protect seeds. So if we are also using the seeds for international scientific research, that would be an additional use for the seed vault, which would be answer choice B. So they said it's for storing and protecting the seeds, but if they're using them for scientific research, that is an additional use. That's not just storing and protecting seeds, that's experimentation or whatever. So that's in addition. In addition, the Svalbard Global Seed Vault has played a role in supporting international scientific research. All right. Yep. Okay, number 4. Various global monetary systems have evolved over time. Under the gold standard, the value of a country's currency is directly tied to a specific quantity of gold. Blank 1 ounce of gold could be directly exchanged for a specific amount of currency under this system. So we just need a nice additive transition here. For instance, 1 ounce of gold could be directly exchanged for a specific amount of currency under this system. We don't need an adversarial transition to move us in the opposite direction. It would make no sense. Yeah. So for instance, or for example, fits right in here. So for example, for instance, 1 ounce of gold is directly worth, I don't know, X dollars or whatever. Last one, number 5. Okay, early methods of creating lighthouse beacons had limitations. In the early 19th century, Augustin Jean Fresnel, a French physicist, created a stepped lens that could reflect light over long distances. Blank, the Fresnel lens dramatically increased not only the visibility of the lighthouse beacon, but the safety of the seas. So here we have a cause, we need a causal transition to illustrate cause and effect, which is C. As a result, the Fresnel lens dramatically increased not only the visibility of the lighthouse beacon, but the safety of the seas. So not too bad, just add up how many you got right out of 5. And I'm going to give you a page number for some book ones. We'll do some book ones, we'll go over them, and then we will be done on time, I promise. Let me just find some random ones from the book. I'll give you a page number. I think we're going to do 10. Let's see. Yeah, we're going to do 10, and then we'll be done. So this is page 169. Page 169. Try these 10. Don't look at the answers. I know the answers are in the back. Give them a real try. I'm going to give you guys some time to try these all. They go easy to hard, just like everything else on the SAT. So the ones at the end are the hard ones. The first one should be pretty easy. So take some time, try all of these, and we'll go over them, and then yeah. So give these ones a try. Okay, I'm going to start going over these in the interest of time. I apologize if you're still working on that last one, but let's go over these 10. So it starts with a student note question, but they go easy to hard, so this one should be pretty easy. While researching a topic, a student has taken the following notes. Always read the prompt. The student wants to emphasize Wu's most well-known achievement. So that's all I'm looking for. I'm going to read the bullets. Annie Wu is a prominent American flutist who graduated from New England Conservatory. She has won multiple national flute competitions. She is best known for a 2011 YouTube video that has been viewed over 2 million times. So that's what I was looking for. The video shows her performing 3 beats for beatbox flute, an original work by this composer. Wu combines flute playing and beatboxing in the video. Okay, so I'm just looking for that third bullet in an answer choice. A. Among her many achievements, prominent American flutist Annie Wu graduated from New England Conservatory and has won multiple national flute competitions. That's not what she is best known for. Annie Wu is best known for the YouTube video. So that was an easy one, but they get harder, obviously. Let's see if the next one's any harder. All right, student notes. The student wants to present the study's findings to an audience already familiar with thermal inversions. Okay, here we go. While researching a topic, a student has taken the following notes. A thermal inversion is a phenomenon where a layer of atmosphere is warmer than the layer beneath it. In 2022, a team of researchers studied the presence of thermal inversions in 25 gas giants. Gas giants are planets largely composed of helium and hydrogen. The team found that gas giants featuring a thermal inversion were also likely to contain heat-absorbing metals. One explanation for this relationship is that these metals may reside in a planet's upper atmosphere, where their absorbed heat causes an increase in temperature. All right, so the student wants to present the study's findings to an audience already familiar with thermal inversions. I'm going to go through some of these answer choices and let's see if I can eliminate some of them. I'm going to consider B. B says the team studied thermal inversions in 25 gas giants, which are largely composed of helium and hydrogen. So answer choice B has no finding. Just tells me that they studied them, but it doesn't tell me what they found at all. So B is out. What about answer choice D? Heat absorbing metals may reside in a planet's upper atmosphere. So D doesn't even mention that we're talking about gas giants. Gas giants. D is out. They couldn't even tell us what they're the type of planet they're studying. Okay. So it's either A or C. This is a harder one. I don't know. This is pretty hard for number two. A says gas giants were likely to contain heat-absorbing metals when they featured a layer of atmosphere warmer than the layer beneath it, comma, researchers found. This phenomenon is known as a thermal inversion. So is that the best way of phrasing the information? Or how about C? Researchers found that gas giants featuring a thermal inversion were likely to contain heat-absorbing metals, which may reside in the planet's upper atmospheres. Okay, so answer choice A, it has a sort of a strange pause to it, and the information is kind of presented in a backwards order compared to C, which makes me want to choose C, but there's even better reason why it has to be C. Why are we explaining what a thermal inversion is to an audience already familiar with what a thermal inversion is? I wouldn't need to explain what a thermal inversion is to this audience, and C doesn't bother. It just mentions that it's a thermal inversion. So, however you kind of spotted the issue, whether you noticed this pause was kind of clunky here, but most importantly, answer choice A, mainly it's just explaining what a thermal inversion is to an audience that already knows what a thermal inversion is. So that's why this one's C, but they're definitely getting way harder. Number one was like a piece of cake, and then this is like a tricky one. So I'm gonna keep moving to number three. Okay, the student wants to always underline what the student's trying to do. The student wants to emphasize the thoroughness of Ida Tarbell's investigation of the Standard Oil Company. Okay, muckrakers were journalists who sought to expose corruption in U.S. institutions during the Progressive Era. Ida Tarbell was a muckraker who investigated the Standard Oil Company. Okay, if anything here seems incredibly thorough, maybe we need it. She interviewed Standard Oil Company executives, oil industry workers, and public officials. Sounds pretty thorough. She examined thousands of pages of the company's internal communications. That sounds very thorough, including letters and financials. Her book, The History of the Standard Oil Company, exposed the company's unfair business practices. All right, the student wants to emphasize the thoroughness of Ida Tarbell's investigation of the Standard Oil Company. Answer choice A, Ida Tarbell not only interviewed Standard Oil executives, oil industry workers, and public officials, but also examined thousands of pages of the company's internal communications. So that's very thorough. That one was answer choice A. All right, number four. The student wants to explain an advantage of the new platinum catalyst developed by Jumbo Tang and his colleagues. Which choice most effectively uses relevant information from the notes to accomplish this goal? All right, so here are the notes. Platinum is a rare and expensive metal. It is used as a catalyst for chemical reactions. Platinum catalysts typically require a large amount of platinum to be effective. Researcher Jean Tang and his colleagues created a platinum catalyst that combines platinum with liquid gallium. Their catalyst was highly effective and required only trace amounts of platinum, 0.0001% of the atoms in the mixture. The student wants to explain an advantage of the new platinum catalyst. All right, I'm going to consider answer choice A. Answer choice A says, like other platinum catalysts, the new platinum catalyst requires a particular amount of the metal to be effective. Wow. Like they really went to some lengths to not explain that point zero, what is this? 0.0001%. Okay, drop the percent sign, make a but. This is 5 zeros and a 1. This is 1 times 10 to the negative sixth. That's how much platinum we need in the mixture. So I guess it is an amount of platinum. They're not lying. It's a crazy tiny amount of platinum. Okay. B, while still highly effective, the new platinum catalyst requires far less of the rare and expensive metal than do other platinum catalysts. That's why we care. Yeah, so that's the whole point of this passage. We only need trace amounts of the platinum, unlike the other catalysts. Platinum catalysts typically require a large amount of platinum. All right, so on to the next one. The next one's about pineapples. I don't have it on the screen, so I'm just going to read it. While researching a topic, a student has taken the following notes. So the student wants to explain how pineapple extract increased the growth rate of P. javanicus. All right, I'm going to go through the notes. P. javanicus is a species of commercially raised fish. Researchers in Indonesia recently found that adding pineapple extract to fish food increased both the feed utilization efficiency and the growth rate of P. javanicus. Adding the pineapple extract did not affect total food consumption. The researchers thus determined that the increased growth rate resulted from the increased feed utilization efficiency. The enzyme bromelain in pineapple extract enhances the hydrolysis of ingested proteins. This allows the fish to more readily absorb them. Okay, so which answer choice explains how pineapple extract increased the growth rate of P. javanicus? Answer choice A says researchers in Indonesia recently found that adding pineapple extract to fish food increased the growth rate of P. javanicus. So answer choice A had no explanation. So it didn't explain how the pineapple extract increased the growth rate. B says an enzyme in pineapple extract, bromelain, increased the growth rate of P. javanicus by enhancing the hydrolysis of ingested proteins, in turn affecting the fish's total food consumption. Well, that's just wrong. We know it didn't affect the food consumption from bullet point 3. Adding pineapple extract did not affect total food consumption. So B is also out. C says, according to the researchers, the growth rate of P. javanicus was affected not by food consumption, but by feed utilization efficiency. Answer choice C has no mention of pineapple extract at all. Answer D is the correct answer choice here. The enzyme bromelain enhanced P. javanicus's absorption of ingested proteins, increasing the growth rate of fish-fed pineapple extract. Okay, now we're doing the sign language one. Oh, now we're on to transitions. A 2017 study of sign language learners tested the role of iconicity, the similarity of a sign to the thing it represents, in language acquisition. The study found that the greater the iconicity of a sign, the more likely it was to have been learned. Blank, the correlation between acquisition and iconicity was lower than that between acquisition and another factor studied, sign frequency. Okay, so did they ever make you learn the sign language alphabet? Did they still do that? No. This is the letter J. And I remember this, I don't know how many years later. That's iconicity. The similar of the sign to the thing that it represents. Isn't that crazy? I still remember that's a J, so I guess it does work. Blank, the correlation between acquisition and iconicity was lower than that between acquisition and another factor studied, sign frequency. So it would make sense that it's more important how much you're signing as far as the learning of the sign than the iconicity of the sign. But still, anyway, we need an adversarial transition to make a concession to move us into the opposite direction. Granted, the correlation between acquisition and iconicity was lower than that between acquisition and another factor studied, sign frequency. I'm running out of time, so I'm going to try to go quickly here. All right, on to number 7, just a few more. Okay, it's another transition question. Before the 1847 introduction of the U.S. postage stamp, the cost of postage was usually paid by the recipient of a letter rather than the sender, and recipients were not always able or willing to pay promptly. Blank, collecting this fee could be slow and arduous, and heaps of unpaid for, undeliverable mail piled up in post offices. So here we just have cause and effect. So if we require recipients to pay the postage, then they will not pay the postage. So consequently, so if this, then that. They're just a causal transition. So consequently, collecting this fee could be slow and arduous. Just cause and effect. That one's not too bad. Number 8. The number of dark spots that appear on the sun, known as sunspots, can vary greatly. For example, there were about 180 sunspots in November 2001. Blank, there were only about 2 sunspots in December 2008. All right, so 180 sunspots in November 2001, only 2 in December 2008. We are comparing them. We do need by comparison. So just a simple comparison, just comparing 180 to 2. Yeah, they're not similar. They're very different, right? Last couple, 9. It has long been thought that humans first crossed a land bridge into the Americas approximately 13,000 years ago. Blank, based on radiocarbon dating of samples uncovered in Mexico, a research team recently suggested that humans may have arrived more than 30,000 years ago, much earlier than previously thought. So this is unexpected. This number is much different than the previous number. I am surprised. I do need an adversarial transition to subtract something to move me into the opposite direction. However, based on radiocarbon dating, seems like it's 30,000 years ago. So much different. The last one is about Henry James. I'm just going to quickly read it because I'm out of time, and yeah, we'll just do this one and we're done. The writer Henry James was known for revising his novels and stories substantially after their initial production, often altering dialogue, expanding description of characters, and including prefaces in later editions of his works. Indeed, the disparities between editions could be quite stark. In the case of James's novel, A Portrait of a Lady, some critics regarded the 1881 first edition and the 1908 revised edition as essentially two different novels. So that one was answer choice A. Add up how many you got right out of 10. If you only missed one, you're definitely in the 700s. If you missed two, you're probably in the 600s or so. But yeah, that's all I have, and we're out of time anyway. Any questions? We have one more class. So next Wednesday, we're just going to do data and statistics, a little bit of English review, and then you'll be ready for the SAT. So any questions? You guys good? And if you guys are good, I'm good. All right. Have a great evening and great job. See you guys.